Mhm. Hello everyone, this is Lexter Del Tison. For number 5, for chapter 5, application of integration, we need to find the area of the shaded region. This is the shaded region. Now, to find the area of the shaded region, we should look at both functions and be sure you can deduce which is we have the given y1 is equals to 5x minus x squared and y2 is equals to x. Now to find the area is we have to of the both function, we just deduce the area is equals to 5x minus x squared minus x. The key to this chapter is remembering to take the topmost function minus the bottommost function when integrating with respect to x. Uh, for the integration is equals to area is equals to integration to 0 to 4 4x minus x squared dx. The intersection points for these curves are 0 0 and 4 4. Therefore we know our limits and can proceed. Now they have to evaluate the area from 0 to 4 is a area is equals to 4x squared over 2 minus x cubed over 3. We evaluated this formula from 0 to 4. Now we can solve this process by standard integration procedure using the power rule. Now using the power rule is equals to area is equals to 2x squared minus x3 over 3 on interval 0 4. Now we just substitute 4 to the x. It's equals to 2, substitute 4 to x, 4 squared minus 4 cube 3 minus 0, the value 0, and a is equals to 32 minus 64 over 3. Now you can find the area of the shaded region. The area of the shaded region is equals to 32 over 3. That is the area of the shaded region, 32 over 3. Now for number 2, we need to find the shaded region of this part. When finding the area between curves, you subtract the lower curve from the higher curve in order to get the positive result. In this case, the shaded region, in the given shaded region, the lower curve is y equals to x squared minus 4x. So you subtract that from y is equals to 2x. To answer that is you have to set the area integration from 0 to 6 and 2x minus x squared minus 4x dx. That is the formula to you subtract the lower function to the higher function. To solve this is equals to integration 0 to 6 2x minus x squared plus 4x dx, and then x equals to integration 0 to 6 multiply and 6x minus x squared dx is equals to 6 1 half x squared minus 1/3 x cubed. 6 from 0 to 6 is equals to 3x squared 6 minus 1 over 3 x cubed from 0 to 6. Now to find the area is you have to equals to 3. Substitute the higher limit to x for the first function. 3 6 squared minus 1 over 3. Substitute the 6 from x. 3 minus, you have to subtract the this two and substitute 0 from x. 3 times 0 squared minus 1 over 3 0 cube, which means that is equals to 3 times 36 minus 1 over 3 times 216 minus 0 0 means 0 0 is equals to 3 times 36 108 minus divided by 3 722. Now the area of the shaded region is equals to 36. The area of this shaded region is 36. Now for number 3, we need to find the area of this shaded region here. Now in this case, we integrate with respect to y. And you can see in this graph that the lower curve is y is x is equals to y squared minus 1. So we subtract that from x is equals to square root of y. And next is finding the area of the shaded region is equals to integration from 0 to 1 square root of y minus y squared minus 1 dy is equals to 0 to 1 is equal to square root of y minus y squared plus 1 dy, and next is equals to 2 over 3, integrate this by 2 over 3 y 3 over 2 raised to 3 over 2 minus 1 over 3 y raised to 3 from 0 to 1, and then simplify is equals to 2 over 3, substitute 1 from y 1 3 over 2 minus 1 over 3 1 raised to 3 plus 1, and the next part is just substitute 0 from y, so you get 2 over 3 times 0 raised to 3, which means 0 minus 0 plus 0, and then next is 2 over 3 minus 1 over 3 plus 1 is equals to, just simplify 2 minus 1 plus 3 over 3 with the same denominator is equals to 4 over 3. Now we find the area of the shaded region. The area of the shaded region is 4 over 3. The area of the shaded region here is 4 over 3. Now for this one, you need to find the area of the shaded region here. Now, to find the area of the shaded region here, you need to consider the functions. Fy and Gy such that Fy is greater than equal Gy for y belongs to CD. The area bound between x is equals to Fy and Gy, and the horizontal lines is yx equals to C and D, and it's given by the area is equals to CD Fy minus Gy dy. From the graph we can see that 2y minus y squared y2 minus 4y on the interval y belongs to 0 and 3. Next is find the area of the shaded region. You know these two. Just a is equals to 0 to 3, 2y minus y squared. Just subtract it from the lower y squared minus 4y dy is equals to 0 3, 2y minus y squared minus y squared plus 4y dy is equals to 6y minus 2y squared dy, and then just integrate is equals to 6y 1 plus 1 over 1 plus 1, then minus 2y 2 plus 1 over 2 plus 1 0 3 is equals to 3y squared minus 2y cubed over 3 0. And next is integrate using product rule is equals to 3 times 3 squared minus 2 times 3 squared over 3 minus 3 times 0 squared minus 2 times 0 3. Just substitute is equals to 3 times 3 squared minus 2 times 3 squared minus this part is 0. So you just evaluate the equation is equals to 3 minus 2 3 squared is equals to 9. Now the area of the shaded region is equals to 9 square units. This is the area of the shaded region. Now for this exercise we need to graph y is equals to x squared minus 2x and y is equals to x plus 4. This is a parabola with the graph look like this. So look like this, and we need to find the area and the intersection of the to find the integration limits. Now, the width of the approximating rectangle is equals to delta x, and the height is equals to x plus 4 minus x squared minus 2x. And to find the intersection, which will be the integration limits, is look like this. X squared minus 2x is equals to x plus 4, x squared minus 3x minus 4 is equals to 0, x minus 4, x plus 1 equals 0. So the integration limit is equals to x is equals to minus 1 and 4. This will be the integration limit. So this is the intersection. Minus 1 and 4, minus 1 and 4, so minus 1 and 4. And this will be the height, and this is the height. Height is equals to x plus 4 minus x squared minus 2x, and the width is equals to delta x. Now we need to find the area. The area, this whole, we need to integrate y is equals to x squared minus 2x minus subtract to y is equals to x plus 4, and we need integrate is equals to, and you know the limit is minus 1 and 4, so set the limit to minus 1 and 4, x plus 4 minus x squared minus 2x dx is equals to minus 1 and 4, x plus 4 minus x squared plus 2x dx is equals to minus 1, 4, 3x, just to need to arrange, plus 4 dx is equals to 3 over 2 x squared minus 1 over 3 x cubed plus 4x minus 1, 4. Next is equals to 2, 3, 24 minus 64 over 3 plus, oh no, because this substitute 4 to x and subtract this equals to 3 over 2, 4 squared minus 1 over 3 times 4 cubed plus 4 minus 3 over 2 was minus 1 plus substitute minus 1 from x is equals to 1 over 3 multiply, substitute minus 1 to x, y equals to minus 4. Then just simplify all the numbers. Is equals to 24 minus 64 over 3 plus 16 and minus 3 over 2 minus 1 over 3 plus 4, and you have to find the least common denominator for all of this to make it easy. And the common denominator is 6. 144 minus 128 plus 96 minus 9 minus 2 plus 24 is equals to 125 over 6 or 20.83. This is the final answer. Now for this one, we need to sketch y equals to x squared and y equals to 4x cubed and find its area. First, we need to sketch the graph. The graph of x squared is going to look like this, and the graph of y equals to 4x minus x squared is going to look like this. This is y equals to 4x minus x squared, and this is y equals to x squared. Now we need to find the intersection. To find the intersection, we must set these two equal. 4x minus x squared is equals to x squared, and 0 is equals to 2x squared minus 4x. This is with respect to x. 0 is equals to 2x x minus 2, and then find the intersection is equals to x is equals to 0, 2. This is the intersection, and next is we need to find the area. Finding the area is just have to integrate. The limit is 0 and 2 equals to 4x minus x squared minus x squared dx is equals to 0 to 4x minus 2x dx is equals to 2x squared minus 2 times 1 over 3 x squared, x cubed, 1 over 3 x cubed, 0 to 2 is equals to minus 2 over 3 times 2 raised to 3 minus, substitute 0 to x is equals to 0 minus 0 is equals to 8 minus 16 over 3 is equals to 24 minus 16 over 3. Just find the common denominator. Is equals to 8 over 3 or 2.67. The area is equals to 2.67 or 8 over 3. The next one is number 20. We just like the previous one, we need to sketch and find the area of this given. X is equals to y raised to 4, y is equals to square root of 2 minus x, and y is equals to 0. First, we need to sketch. Y is equals to y4, like this, and the next one is y is equals to square root of 2 minus x. This is square root of 2 minus x. This is y equals to y raised to 4. This is 0. This 1, 1. This is 1. This is 2. This 1. And next is finding the intersection, or going to be the limits of help us finding the area. Find the intersection is just easy. This is y squared is equals to minus x, y is equals to minus y squared, and y4 is equals to 2 minus y squared, 0, y4 plus y squared 2 is equals to just common factor is equals to y squared plus 2. So like y plus 1 and y plus 1. And we just find the value of y. Y is positive or negative 1. Positive or negative 1. And x is equals to positive or negative 1 raised to 4 or 1. And to find this is our limits. These are limits. And finding the area of this is we just need to integrate to find the area. Area is equals to, the limit is from 0 to 1, 0 to 1, 2 minus y squared minus subtract to y4 dy respect to y is equals to 2y minus 1 over 3 y 3 minus 1 over 5 y 5 0 to 1 is equals to, just substitute 1 to y, 2 minus 1 over 3 minus 1 over 5 minus substitute 0 to y, and this will become 0 minus 0 minus 0, and it's going to be 0. It's equals to this common factor, this common denominator is 15, and that's 30 minus 5 minus 3 is equals to 22 over 15 or 1.467, and this is the area of our problem, 22 over 15 or 1.467. That is the area. Now for number 47, there are two cars, car A and B, start side by side at the point at the origin and accelerates from the rest. Now the question is, for A is, which car is ahead after 1 minute? So as you can see in the graph, the area between A and T axis is greater than the area between B. and t-axis. This is the area between B and t-axis at 1 minute. So the distance traveled by air is greater and car A is ahead. To make it simple, it's going to look like this. T, this is 1 minute, and this is A. This is the area. This is the area traveled by A, and after 1 minute, and this is the area traveled by B. Just looking between these two graphs, you can see that the area or the region between A and T axis is greater than the region between B and T axis. So car A is ahead after 1 minute. Now for letter B, what is the meaning of the area shaded region? So the meaning of this area is the distance which car A is ahead of car B after 1 minute. Is this going to the distance between car A? Time dt minus integration 0 to 1 velocity of p time. The area, this is going to be the distance which car A is ahead of car B. This car A and this is car B is equals to the distance ahead of car A. The difference in areas under the curve represents in distance. This is the meaning of the shaded region. Is the distance ahead of car A. And for letter C, each car is ahead after 2 minutes. So after 2 minutes, car B is traveling faster than car A because the slope of the tangent line at curve B at t equals to is steeper. You can see, as you can see in the graph. This is the slope of the car B, and it's steeper than car A. So car B is traveling faster than car B. However, the area under the curve A, the area under here, the curve A from 0 to 2 is still greater than the area of the curve of car B. As you can see, we just make it simple. What I'm talking about is, as you can see, this is the area of the car A. 0, 1, 2. This is the area of the car A, and this is the area car B. 0, 1, 2. The area under the car A is still greater than the area under the car B, as you can see on the t equals 0 to t equals 2. So at the, car A is still ahead from car B because of the area under car A is still greater than the area under car B. And for letter D, estimate the time at which the cars are again side by side. So just go to another paper for you to for me to explain it very well. So as you can see, the area uh, the area below each car's velocity represents the area below the car's velocity represents the displacement of each cars. Therefore, when the displacements are equal, the two cars will once again be side by side just as they were at the origin. So car A and car B will be side by side when the area under curve A is the same as the area under this area is the same as the area under the curve B. So from the graph, it appears that T equals 2.1 minute. It's going to look like this because we're not sure, just an estimate. They will have the same area. T equals 2 minutes. They will have the same area, car A and car B. This is just an estimation and there's no definite answer. But I try to look at the graph and just say like just estimate 2.1 minute they will have the same area as car B. So this is my assignment and my name is Lexter Dale Revolution and thank you for listening and watching. Thank you.